Greetings to everyone. My name is Kunita Nagwani. Today I'm going to present my topic on SLR Parsing Table Construction application in simple Paris rules. This topic is an important part of compiler design and help us understand how programming languages are analyzed using parsing techniques. Now let us first understand the main goal of this topic. The main goal of this is to understand how parsers work. Parsing in the processing of checking whether an input program follows the correct grammar or not. This process is based on deterministic finite automaton. It is also called DFA. In LR parsing, a DFA is constructed to recognize valid language constructions and identify reduction points in code. SLR, which stands for Simple LR, is a basic method used to generate parsing table. So it serves as foundation for more advanced parsing techniques used in modern compilers. Now let us understand what an LR item is. An LR item is an production rule with a dot that shows the current position of the parsers. The dot indication how much the rule has been processed. For example, E is to dot E plus T means parsing has not started. E to E dot plus T means E is already seen and the next we expected plus. E to E plus dot T means we have seen E plus and now expected T. E to E plus T dot means the rule is complete and ready to reduction. So the dot helps tracking passing step by step. Now I'll explain the closure operation. Closure is used to expand the set of LR items. If the dot is used a non-terminal, we must include all production of that non-terminal. For example, if we have F2 dot E, since the dot is before E, we include E2 dot E plus T. So E2 dot T. This process continues until no new items can be added. It ensures that all possible parsing options are considered. After that, let us look at the go-to operation. The go-to operation is used to move on from one state to another. First, we find items whether the dot is before a symbol. Then, we move to the dot over that symbol. Next, we apply closure to the next set. Finally, we create a transaction to a new state based on that symbol. So, go-to helps build connections between the status. Now let us see how we construct the conical LR collection. This steps builds all possible states of the parsers. We start with augmented grammar state 0 equal to closure of s dash is dot s. Then we apply the goto operation on all states and symbols. Whenever a new set is formed, we create a new state. This continues until no new states are generated. The final set is called conical collection. Now let us understand the LR0 automaton. The LR0 automaton is graphical representation of parser state. States are shown as circles and transactions are allowed labeled with the grammar symbols. It shows how the parsers move step by step while processing in the input. Now we move to the most important part, which is building the SLR1 parsing table. The SLR1 tables contain LR0 states with follow sets. These are four actions. Shift means moves to next slide. Reduce, it is an apply a rule when dot is at end. Accept means parsing is successful. Go to means transactions on non-terminals. These actions forms the parsing table. Let us now look at an example to understand this better. Now consider the grammar E plus T or T. T is for T into F or F. F to E or ID. Follow sets are follow of E is plus or dollar, follow of T equal to plus or dollar, follow F is plus multiplication and dollar. Using this, we fill the parsing table with the shift and reduce actions. Now let us understand the importance of SLR parsing. SLR parsing provides a structured way to recognize varied programming constructions. It forms the base of advanced techniques like LALR and LR1. It is essential for understanding how compiler works. Finally, let us look at the application of SLR parsing. SLR parsing is used in a compiler designed for syntax analysis. It helps construction parsing table using LR0 items and follow sets. It is used in a simple parser tools to check program structure, and it ensures correct grammar and helps in error detection in source code. It is also used in basic compilers, interrupters, and educational tools. It forms the foundation of advanced parsers like LALR and LR1. That brings to the end of my presentation. Thank you.